Okay, so as promised, today we're going to talk about fragments and debugging. If you're just announcements, just so they're in the slides, so then when you download them, you know if you're at home or whatever. Homework 2 due Thursday, and project 1 is assigned, so go take a look at that. And we'll cover everything that you need to know in project 1 in the next couple days, so don't worry about that if it looks complicated. All right, so last class we talked about intents. We're just going to do a quick review in case you need the review. So if you remember, the intents allow us to stack different activities on top of each other. That's a hierarchical way of looking at it, but to the user, it just looks like that a screen pops up, a new screen pops up on their interface. And so when you hit the back button, it makes that top screen go away in a nice little animation. And so those little arrows are essentially our intents and also our communication pipeline that we can send information back and forth between these activities. So the intents, to call them, we create a new intent. We pass in two parameters into the constructor. So the constructor in this case, near the bottom, is new intent. Main activity, that's just the activity that we're currently in, .this. It gives a reference to the class that's calling this intent. And it actually doesn't have to be the current one. You could actually pass it another activity if you had a reference to another activity. But almost all the time, at least in my experience, you would just pass the current activity. But it's more than conceivable that you'd have some other class handle that for you if you wanted to. And then finally, the second activity that you actually want to create and display on the screen, maybe on a button press or some other user interaction. Second activity is the class name, and then .class is the reference to that class, the package kind of thing, where this method is going to essentially create a new activity. But that's all you have to do, is just give it a reference to the class so that it can go off and create it. However it's going to create it, we don't know. It happens kind of in a black box. And then finally, we call start activity and then pass that intent to that start activity, and then the Android operating system will create that activity, the activity manager. All right, so that'll launch the screen called second activity and set all that up for you. And then in the second activity, or in the child activities, on create method, we can pull out any information passed into the intent by doing get intent. So this is an activity-based class method, activity method, excuse me, called get intent, and then that passes back the intent, and then from that intent we can pull out different extras, is what they're calling them, from the bundle. And so this was an example. This wasn't in the example previously. We didn't put anything in the particular intent, but when you if you did pass it in there, you can pull this out. And other classes that might call your intent, like the operating system might actually call an intent based on, or might call your application, and it'll pass in some default extras in there. For example, who called you? Like, was it Facebook calling you or something like that actually opened up your application, or was it another application? That sort of thing. So you can pull that information out of these bundles, and to get that, you just give it a constant or a key. So you'll often hear me refer to these as key values, or name. What's the other way of calling these? I never call them this way, but name value pairs, name or keys, same ideas. So you have a key, basically an address to this value. And so if you guys are familiar with Mongo, Redis, those kinds of databases, those all use key value pairs, that sort of thing. So this is a pretty common pattern. All right, so we pull that out, and then when we want to pass information back to the parent activity, again, we create a new intent. This intent doesn't create a new activity. It just allows us to bundle up a bunch of information. In this case, I am just giving it, I'm sorry. I kind of jumped ahead of myself here. This is how, okay, so that's just how to launch an activity and then get information out of it. This is if you want to pass information back. I kind of skipped to the next slide here, but in order to launch an activity where you expect information coming back, instead of using start activity, you use start activity for result. And so you're expecting a result to come back from this launched activity. So The declaration of this looks exactly the same. So intent, new intent object, new intent. Constructor, we pass in these two parameters just like the previous one. But again, instead of doing start activity, we do start activity for result. And then in addition to passing it the intent that we wanted to launch, we also pass it an ID. And this ID is mostly 0, but if you're launching multiple activities or activities of certain kinds that you don't know necessarily who's responding back to you, you give it an ID to figure that out. So most of the time you might want to do just 0 for that kind of thing, but it's there if you need it. And so in the child activity, again, you can pull out the extra and do all that stuff, but on return, maybe you hit a save button or you hit a cancel button or something like that, where you want that activity, that child activity, to go away and return to the parent activity. We create a new intent. We leave this intent blank, and then here we're putting in a name constant. This is our key, and then the value, and I just have in there a variable. You can put in a string. You can put whatever in there, booleans, that sort of thing. And you can put as many of these as you want. So you can have all these put extra, as many as you want in order to pass back enough information to the parent activity. And then finally, you set result saying either result equals OK or it was canceled. And this is really only for your use. It doesn't affect the parent activity in the least. It's just a nice way to handle, okay, did the user press OK or did they press cancel, that sort of thing. And then you pass in the return intent. And then finally, you hit finish, or you execute finish. If you don't call finish, your activity doesn't go away. By executing finish, by calling finish, it finishes the activity, and only then does it give your information back to the parent activity. So make sure you hit finish. In the parent activity, we have this callback. This is an override on the activity class called onActivityResult, and you get a few parameters that you can play around with and see what's passed in there. But the part that we're interested in is our data. And we check to see if it's null because it's possible that the child activity didn't pass anything back. And then finally, we use that data. It's a bundle. So it's a bundle of information with key value pairs in them. We say get string extra in this case. It could be get boolean extra, get float extra, get int extra, that sort of thing. And we give it just the key that we're looking for to pull that value out and put it into string data. I'm not sure if you have to typecast. No, I guess you don't have to typecast it because this one actually is that getter is specific to that class. So
Mike,
yes.
You can also get pass objects.
You can pass objects as long as they adhere to the. You can pass class objects as long as they adhere to the serializable interface. Yeah, absolutely. I don't recommend passing entire classes unless you have a really good reason for it. So if you're, for example, for project 1, you might tap on a, so it's a map, you might tap on a pin on that map to get more information about that pin. You can conceivably have all that information in a class and then pass that class instance to the child activity to display that. But I'll show you a better way of doing that. And so I rarely ever pass large amounts of data through intents. And there's many reasons why, but I can show you a few before, way before project 1s do. Any other questions? Okay, thanks. Okay, so fragments. So we'll talk about fragments, what they are, but they are implemented in an operating system version called Honeycomb. And if you notice anything about Android over the past couple of years, they name all of their operating systems after delicious, well, it depends on your opinion, I guess, but desserts. So there was, it's all ABC order, so there was no A or B or C. I'm trying to remember what the first one is. Cupcake. Yes, thank you. C. So cupcake was C. I was going to say E for eclair, F for froyo or frozen yogurt, G for gingerbread, H for honeycomb, I ice cream sandwich, jelly bean, Kit Kat. And so all these different versions have, candy or dessert names. For, well, we're currently on marshmallow, if you guys are curious about that. That's version 5. And it's not always like version 1 is, one and version 2 is another one. Version 4 was Jelly Bean, and I think 4.4 was Kit Kat. Yeah, it's hard to remember all these because we have API versions, we have operating system versions, and then we have names of operating systems like Honeycomb, that sort of thing. But anyway, Honeycomb was version 3.0 if you're curious, and this is the first implementation where we find fragments and the use of fragments. And so fragments, well, yeah, I don't want to dive too deep into right now, but the fragments that you can use fragments before Honeycomb, but one, I don't recommend producing an app anymore before Honeycomb, which is 3.0, and I really don't recommend producing an app that supports anything before 4.0 or even 4.1 for that matter. But 4.0 is a good kind of cutoff point because anything before that, one, doesn't support fragments, and two, has a whole other bunch of issues that you have to support, backwards compatibility. And so all activities that are implemented after Honeycomb, they don't know anything, or excuse me, all activities that were implemented before Honeycomb don't know anything about fragments. And so in order to support that before Honeycomb, you have to use something called a support library. So you might see in your class names support or an abbreviation of support. I can't remember off the top of my head what these are, but you might see that. And so that's a way of backwards compatibility, but hopefully we won't have to worry about that in that class too much. You might accidentally import that class rather than the future classes. For example, activity has a support activity class that supports backwards compatibility with that. So hopefully you don't need to worry about that. And then finally, the last point here, fragments allow us to finally have different layouts to be used in an activity. So now we can get, if you guys are familiar with single page web applications where it doesn't have to reload the website every time you click on a button, but instead makes it like an AJAX call and then it dynamically loads the content into pages and kind of injects it all over the page. That's kind of how fragments work. These are reusable little tiny pieces of user interface goodies that we can slap on the screen, reuse it, use the same class. And example is the map view that we're going to be using is a fragment. So we can slap that almost anywhere. It has its own code that's associated with it, and we can use that same code base on different either activities or in other fragments. All right, so just like our activity, and don't worry if this is going over your head right now, it's kind of going to ease you into it, but our fragment lifecycle, you can think of a fragment. I kind of drew this on the board last time, but let's pretend that our application here, that surrounding window, the big box on the outside, is our activity. And then on the inside, we can have smaller boxes. And maybe up here we have, a map, and let's say that's the map of Antarctica or something like that. And then down here we have some interface widgets, like a button or something like that. This is submit, this is cancel, this is like a text field, that sort of thing. Or a face, I would say face. And you can think of these inner boxes as fragments. And so what fragments are, they're basically like mini activities. You can kind of think about them that way anyway. And they each have their own life cycle. So here's a diagram of the life cycle. And in the top left-hand corner, we have the new state. And so this is obviously when it's coming to be created. And we have 3 different methods before it actually gets into the created state. We have onAttach. We have its own onCreate in there. So just like an activity, we have onCreate. But you're probably actually more interested in the fragments case anyway of the onCreateView method. And that's when the view of the fragment has been created. So views themselves have these little kind of other views, and they have layouts just like activities do. So that's when the that's when the fragments layout is actually created so that you can get references to buttons and everything is in the onCreate view. So a little bit different than activities, but there it is. It goes right into the create state, and then from there we have the stop state, we have the pause state, we have the running state, that sort of thing. And it has its own callbacks for those different states: on start, on resume, on pause, on stopped, back to the stop state. And then finally, we have, going from the stop state up to the upper right-hand corner, we have this kind of conditional logic here that says, are you retained? Meaning, do we have a pointer or do you have a reference to this fragment object? And if no, it goes into the destroyed state. If yes, it actually gets detached and it goes into the retained state so that we can reuse it later. And what this means is, let's say, based on this user interaction below here, my little diagram that I drew on the board, if, let's say you click this button or click this button, let's pretend these aren't submit and cancel, but let's say you select this button, and these buttons are satellite view and let's say terrain view, okay? Well, that's probably a bad example. Let's say, because I actually want to switch the frame. So let's say map view. This will actually be project 2, sort of. Map view and list view. Now, when I click on map view, I want to show a map, obviously. So this is going to be our map. When I click on list view, I want to take this fragment out of the user interface display. I'm going to stick it over here. Let's pretend, this is memory or somewhere over here. So this goes off screen. You don't see it anymore. And then what we want to bring in is a list view. I'm just going to draw it over here. And pretend maybe we've created that in the background, because usually you want to create stuff in the background so that when the user clicks on it, it doesn't take time for these things to be generated, and then finally there's no delay. We bring this onto the screen, and this is our list view, which just lists out. Let's say we have, Antarctica, we have the South Pole here, and in our list view, we have that in text. And maybe there's the March of the Penguins kind of thing, right? There's maybe this is where the March of the Penguins took place, that sort of thing. And so we're having the same information, but they're being displayed in two different views. One is in a list view, one's in a map view, and we want to be able to switch those in and out as we select another user interface. This is just one example. You can use fragments for almost anything you can conceive of. Fragments themselves may not actually have a layout. You can just use them with no interface. That happens too, just like activities. Sometimes activities don't have layouts either, but that's kind of rare, but there's reasons for that too. Now, when I take this map off screen and I replace it with the list view, I don't want that information to get destroyed. I want to kind of retain it, because if the user is going back and forth between these two views, I want that to be fast. So basically swapping these in and out as the user selects these buttons. And so if you have a reference to it, meaning the class has a pointer to, well, not a pointer because you guys don't know about pointers in Java. If you have a reference to it, like a variable, class variable, that sort of thing, class member pointing to one of these guys, then the operating system will retain that. It won't garbage collect or anything like that. And it'll go into this retain state. And then if maybe I don't care about that information, it's possible that that gets destroyed as well. But these things are a lot better than activities, where the activities get destroyed when you rotate. So if you put everything in a fragment, the fragments might actually get deleted, but only in certain instances. There's ways to keep fragments around. But again, if this is going a little bit over your head, don't worry. You don't actually have to know about half of this stuff on the screen to work with fragments, but at least you're seeing it now, and when things start acting up, or you need to execute code during different phases of this, you'll see. You can go back to this diagram. Okay, so how do we create a fragment? Well, we can create a fragment either in our activities layout file, and then including that, or we can create it programmatically. So usually the way to do it is programmatically, though I think some of the defaults just set it up in the layout, and then it has a reference to the fragment layout, yada, yada, yada. It is a class that extends fragment. Now you might see other classes that kind of resemble that last term there, fragment, support fragment, that sort of thing, but for the most part it's just fragment. And so we have again, on fragment, we have an onCreate. This is similar to the activities onCreate, but the activities onCreate is protected. And so we can't access this from other other classes. But the fragments constructor, well, not the constructor, but the onCreate is public. So we can call this from another class. So this is kind of nice, where we couldn't do this before with activity. And you wouldn't want to do it with activity just based on the way that activities work. Okay, so the onCreate view, this is where we actually take the fragments view file, that XML file that we use, and it pulls it in, it inflates it, and then you can put that onto the screen. And so we have an inflator, we have a parent view group, which we'll talk about in a second, and then we also have the saved instance state stuff for when a fragment is destroyed. But a fragment is a lot more flexible in terms of when it gets destroyed. Now, for inflating the layout, this is pretty simple, though it's a bunch of code. And don't worry, Android Studio mostly takes care of this for you, so you don't have to remember this off the top of my head. I never do, so no worries. What we're going to do is we're going to create a view object. Usually this is either a layout or whatever, but I don't really care for the most part, so I'm just going to create a view object called some fragment view. I'm going to use this kind of, not imaginary, but it kind of just comes out of nowhere. This variable called inflator. It's part of the fragment class. It has a reference to the inflator. It's basically the operating system's inflator, and it's calling inflate. And then we pass it a layout, and in this case, r.layout. That'll give us all of our layouts in the Android system, or at least in our application. .fragment some layout. This is just what I called this example. And then you're going to pass it a container in which to put that view into, and then should I attach to the root? Yes or no. That's just a Boolean value. And then finally, we can get references to our UI elements. So text view, some fragment view, find view by ID, r.id.hello text view. So if you notice, this looks almost exactly like the same way to get a UI view in our activity, but because our UI elements are contained within our fragments, we have to do one more step. We have to reference the fragment that it's contained in this case, some fragment view. So let's just abbreviate this, some fragment view, and maybe this is called another fragment view, right? And those are just variables. So we're specifically asking some fragment view, go find this view, either a button or a text view or something like that, by ID. Because theoretically, we could have fragments. These two could be the same fragment. These two could be both map views. And so we want to be specific of how we get a reference to this button, or how we actually get a reference to the Google map, for example. Because when we reference this fragment, we're not actually getting a reference to the Google map. We have to use the same technique. And it might be called map fragment view .find view by ID. But there's actually other ways that the fragment implements in order to get that map. And we'll go over that next class, but just so you're hearing it now. Then the fragment manager handles all of the fragment allocation and stacks and everything like that, just like our activity manager does. And this is mostly in the background, but we have to be a little bit more explicit when we're talking about fragments. So fragment manager, and I'm just calling fragment manager in this example, get fragment manager. So this is asking the operating system for our app's particular implementation of the fragment manager, and that's going to return a reference to that. And then in the fragment manager, we can call fragment manager.find fragment by ID if we just want the fragment, r.id.fragment container, and then we're going to store that into an actual class called fragment some fragment. Now, if you remember back a couple slides in the declaration of the fragment, public class some fragment extends fragment. Well, some fragment is actually your implementation of this fragment class. And so when we go back to this slide, you replace fragment with your class implementation. Or you can keep it as the superclass, but then you don't get access to its custom methods. And we'll go over this again in actual code. Now, fragments might already exist. So maybe you rotate the screen, the activity gets destroyed, but your fragment still exists somewhere. Well, you have to check to make sure that fragment comes back from the fragment manager intact. And if it does, then skip this initialization step. But if it does come back as null, meaning it hasn't been created yet, then go ahead and create these steps. And so this is the actual way of creating a fragment, or at least one of them. So I just have one called SomeFragment, storing that into a class member called SomeFragment. And then what we're doing here with the transactions is, let me just read this beginning. So we have this fragment transaction. We begin this transaction. We add a fragment to our view, and then we commit that transaction. Okay, so what does this do? Our transactions allow us to execute multiple steps, and then basically do all that in one shot. So why is this useful? It's useful because what you might want to do is multiple steps before anything is actually executed. So maybe you add a fragment to the screen, but maybe you add another fragment to the screen and remove a third one. And then finally what you want to do is commit all that. Android, the operating system, will handle the transitions of all three fragments coming and going, and you don't have to worry about which order they're in. The fragment manager just handles that for you. So this is one reason why we have this transactional thing. Another reason is because this is actually undoable. It has a, a history for the transaction state. So what I can do is I can add this fragment to this container, this fragment container that we have defined. So I'm adding some fragment that we've defined up here. I'm adding it to some container. This would be a container here, for example. And maybe I want to undo that. I can simply call on the transaction. I forget what the exact method called, but it's something like undo or undo history and that sort of thing, and it'll undo that last transaction. So I don't have to. If I'm doing three transactions or I'm doing three fragments, I don't have to remember what that last order of operation was. I don't have to remember which fragments were added. I can just say undo. So that's another reason. You probably won't get to that kind of level of complexity in this class, but if you do, that's what it is. So again, you don't really have to worry about this. The Android Studio creates most of this code for you. And we have a commit ID in case we want to undo that commit. But anyway, so again, going back to our life cycle here, we have our new state. We have an unattach, we have an onCreate, and we have an onCreate view. And these are well, let's just say the onCreate view is the one that you're going to mostly be interested in. But if you have other needs, they're there as well. Okay, finally, debugging. So you're wondering, how do I do a console log, or how do I do a system.write, or however Java does it on particular platforms. There's so many different ways to print stuff out to the screen. This is printing it out to the debugger in Android Studio, so the little window that pops up at the bottom that all that text scrolls through that you probably never even read, or if you try to, it's super encryptic. You can put your own messages in there. And you can put different levels of logging, and so this is why we have 5 different ways of logging. One, we have debug. This is just debug messages, maybe printing out values of variables, that sort of thing. We have verbose. We have info. So maybe you're just saying, hey, I'm adding this to the database. It's not really a debug message, but it's you're just giving info. Warnings. Hey, I've executed this part of code, or I don't have access to the internet, or this API is down. I'm giving a warning. And then finally, you read this correctly, log WTF. And that stands for WTF. That is actually from the documentation. This is a great thing about teaching this class is I didn't know about that until teaching this class. But as I'm going through the documentation to figure out all the different log levels, there is one in there called WTF. And it just, I don't know. You can use it if you're just wondering, WTF. And for those who don't know what that means, you can look it up. Okay, so let's do a little bit of debugging here. Oops, let's next part. Any questions on fragments? I know it's kind of still very abstract for you. Okay, open up the last project. Okay, so we're going to create a new project. I do believe this is our 3rd project. We're going to call this one Fragments, and I'm going to put it into O3 Fragments folder on the Git repository. API level 15, and I'm still going to create an application with a blank activity with one change. So main activity, activity main, this is all fine. This is all the defaults we've been using all semester. But you might have had this checkbox on by default. I think I turned it off for the first class and it maybe kept it. But in case you don't have that checked, check it. And if you saw this little transition to a dotted yellow line, this is kind of where you can think of as your fragment living. And so if I uncheck that, it goes away and it has this plus button here for, it's just another user interface thing. But so I'm going to use, excuse me, I'm going to have a blank activity with a fragment inside of it. I'm going to hit finish. Give it a second to initialize. Gradle is going to do our build. Gradle also pulls in our dependencies, so things that are external to the project, like maybe third-party libraries, it actually pulls those into the background and then compiles them and does as much as it can do. If you're seeing this, if you're creating a project and putting it into your repository to submit, maybe it's project 1, you might get this this message up in the upper right-hand corner. I keep talking about this, but most of the time you just do add root, and now you can run all of your Git commands through Android Studio. You don't have to do that. I prefer either command line or source tree, but if you are interested in there, up in the VCS menu, we have some Git or version control stuff, specifically Git commands here, but you can create patch files, all that fun stuff in there. Okay, so on first look, it doesn't look that much different. We still have our activity main, and we have our content main, and those don't change because our auto scroll doesn't. Okay, so activity main, content main, and then finally fragment main. And so it pretty much all looks the same, but if you go into the code, you can see in our fragment main is actually where we have our text view, and in this case it just says hello world. And if I go back up to the content main and look at that code, you can see there's almost nothing in there. There's nothing UI related anyway. But what we do have is we have this XML entry called fragment, and then the ID on it is actually called fragment. It has a namespace based on the activity that it's in. Matching parent is the width and the height of the parent that's containing it. So what it's going to do is whatever object is containing it, it's going to match the width and the height. So essentially it's going to fill it up. That's just another way of saying it, but it's going to fill up the parent container. And then finally we have our layout file that this is actually going to reference, in this case fragment main, and where that lives is in our skipping ahead. So in our content main, this is the file that's referenced in our content main. And then going back up again to the hierarchy, in activity main, what this is doing is it is including our layout content main. Okay, and then all of this is contained, or it's from code, it is contained in our main activity. So in main activity, in the onCreate, we have this line of code that sets the content view to r.layout, which again is the class member that contains all of our layouts, specifically our activity main, and that's going to load in that first layout here, okay? And then what that's going to do, what activity main is going to do, if you remember, is it's going to include the content main in this spot here. Content main is going to include the fragment main. Why we have all these 3 different steps? Well, importantly, what this is also doing in content main is not only pulling in the layout, but it's also creating a class called main activity fragment for us. So this is the other way to create a fragment via XML. And what this is doing is pulling in this class. And this class really only has two methods in it. One's the constructor, which we can call publicly now. If you want to pass the fragment any information, we can do so via that means or another means if you want. And then finally our onCreate view, which is very similar to our onCreate interactivity. This is where all the magic happens in getting getting references to buttons and that sort of thing. All that logic goes in the onCreate view. So again, Android Studio created all of this for us, so we don't really have to memorize all these fun things. Let me go to presentation mode. It's a little bit bigger for you. Okay. So in our onCreate, it doesn't really do anything. We're not really getting references to anything, but the main thing that it's doing is inflator.inflate r.layout.fragment main container false. Okay, so starting from the beginning, this is pretty obvious. Ugh, okay. Asked me that like a million times. We're telling this fragment which layout to inflate, because we can, based on logic, maybe we want to inflate different fragments, right? Maybe ones that are similar. But in this case, just fragment main, which is that third layout file that we showed you, the one that actually contains the text view that says hello world. So that's the reference to that. The container is the container that it actually is contained in. This is contained in the content main layout. And then whether to attach to the root. No, we don't want to attach this to the root. We want to attach it to the container within the container. So we set this to false. I think almost always you want to set that to false. Yeah. Yes?
What is a root? Is the
Oh.
use of root here the same as it is in that pop-up box asks you? Is that the same root?
No, that's a good question. So the pop-up box was a reference to the Git root, and adding that to the Git root just essentially takes your project or it lets Android Studio know that your project is under source control, so that you can version files and everything like that. This root refers to the view hierarchy of where you're attaching these views to. So for example, this is the root, this window out here, and then you have these child views that kind of go down. So what this is asking me, do I want to attach this view here to this object? And I don't want to do that. I want to attach it to the container that it's in. So don't worry too much about that. Just set it to false. Again, Android Studio takes care of all that for us. And there's really nothing special about this project. It just, you run it and then it, let's go ahead and run it. I don't have Genymotion running yet, so let's start up a Nexus 7. And this will show up in a second. But we can manipulate this a little bit.
You have a video on Genymotion, right?
Not yet.
Oh.
That was the next one. Yeah, nice. So the question was whether I have a Genymotion, how to install it and everything. If you guys are interested in Genymotion, I'll put a video up there on how to get started with that. It's pretty basic, but there's a couple steps to it. And then especially if you want the Google Apps on it as well. So, okay, so we got this running, and we switch back to our Android Studio. It's up and running there. And again, the one reason I use Genymotion is because it's so much faster. And this will probably switch over to Genymotion whenever that loads up. Okay, so there it is. Nothing special. I mean, it's just the way that we implement this. But again, it allows us to do complex things later on. So let's talk about debugging real quick. Okay, I have this application. It's not working. I don't know why. Let's start from the top. So don't worry about this code for right now. It's just boilerplate code to get the, for example, if you want to remove that thing in the bottom right-hand corner, you can remove this code, and it's in the layout too. You're going to remove it in the layout, but don't worry about that for right now. And I want to do log dot. You can see all the different log levels we have. So WTF is down there. Let's see. So these are the real ones. So log.d is the debug. We have this other one that's just a little bit more verbose. But I'm going to do, well, let's do log.d. Okay, so what it's asking for is two things. You're not just going to print out a string, but you're also going to give it a tag. What I like to do is just mz for me, and then I'm going to say onCreate was called. Okay, and then I'm going to copy that so it's easy for me. I'm going to paste it here as well, but I'm going to say on create options. Oops, I told options menu was called. And then finally, this one I'll put it above the logic. On options item selected was called. And then in our main activity fragment, in here I'm going to say, instead of, just import that library for me, instead of a debug statement, I'm going to just put an info statement, because that's probably a little bit more true to what we're doing. Well, it depends what you want to use it for, but I'll show you why that's important here. And then finally, constructor, let's say fragment constructor. I probably messed up the terms on these, no big deal. So strings, and on create view was called. And again, instead of the debug, I'm going to put I. And instead of the MZ, I'm going to put MZF for fragment, let's pretend. Okay, and I'll expand this debug window. And so as I mentioned, you might see all these things here. Let's take a few lines of code. We have the I for info. We have the W for, well, I don't know what the W is. And then debug here. So debug info, debug info, debug info. You're seeing a whole bunch of statements here. And then we have the Dalvik VM. That's what that is. Dalvik is essentially the VM, the virtual machine that Android runs on. And so this is Android telling you these are the things that are happening. And then down near the bottom here, we have a libegl. This is the graphics library stuff that's spitting out here. We have the EGL emulation, and we have an OpenGL renderer object that's talking to us, essentially, just debugging it, saying enable debug mode 0, that kind of thing. But really, I don't care about that stuff. And so if I switch verbose, which is everything, obviously, we can switch that to debug and just see our debug statements. That didn't actually work. Let's see, info. There we go. Okay, so these are just the info buttons. I'm not sure. Okay, yeah, W is considered info as well. So if I'm just showing info, I do that. And let's relaunch our application. And I'll show you one more thing after this. So it's going to probably launch in the background. I don't really care about the emulator right now. And I think that ran. I guess it ran. It was so fast I didn't even see it. Let me close. I want to get rid of that green button. Okay, there we go. So we have info here, but okay, it took me a while to find the code that I was actually interested in. So fragment constructor was called, on create view was called. That's in my info. If you notice, my other calls were not mentioned, and that's because those are debug statements. If I switch this back over to debug, I can see again somewhere in the middle of this mess. Here it is. These are my debug statements. Oh no, wait, sorry. This one's right here. Debug. On create. So debug also includes the info. And so this is very, very confusing. Here's my other one way down here as well. So very, very confusing. So what I usually do is, because I've named that tag MZ and MZF, is in this little search window here, I can just type in MZ, and that'll give me all of my debug/info in this particular case, but only ones that are tagged with MZ. And if I want to filter that further, I can do MZF. And so this is a really great way of just getting your debug statement. So I can go back to verbose and just type in MZ, and these are just my print statements. And so that might be the way that you want to keep your development environment. Just have that window have whatever initials you want to use, or you can tag these with a particular class name. So instead of like main activity fragment, this is a little bit more common, is to actually put in the class as that tag, but it's completely up to you which way you want to use it. I just prefer, I don't really have that many print statements, or not print statements, log statements here. So, excuse me. Again, I just have usually just MZ for all my print statements. But again, you can use whatever you want. I'll just change that back to everything. And if I reran that, that would all fall under the same tags. This is very, very convenient too for other, not only just your own classes, but let's say I always want to, I'm really interested in this libEGL stuff. I can specify that. If you're having crashes in your application, sometimes the stack trace of what actually happened and which class it crashed in and all that fun stuff is way at the top because it'll crash and then Dalvik will do a whole bunch of other things to clean up your application, kick it out, do a bunch of other things, clear memory, do this, do that, and you have to scroll up several pages equivalent to find that. And so you can actually search that by either error or that sort of thing. You have asserts in there as well, warnings, all that fun stuff. So that's how you use debug filtering. If you still don't understand fragments, don't worry, we'll talk about it in the next class. I just wanted to introduce the concept to you because it is a very complex way of looking at how to do development. So we'll talk about it next class as well when we talk about how to do maps and how to actually integrate a map into your application, because this is really cool. Now we're actually going to be having a useful application, something you can actually click around on, zoom in, have real data. You can see the map of the US, you can zoom in, find your state, that sort of thing, and then GPS locations that we can center in on the map and that sort of thing. So don't worry if you're, we're 2-3 weeks into this class, we haven't really done anything useful. We'll get to that next class, I promise. I still have more material for you, don't worry. Okay, so debugging, all that fun stuff. Toasts. This is another way of debugging. So the reason why I'm introducing this early is because you'll probably find yourself hacking away at this stuff and you're just like, why is this not working? Well, you could either use the debug messages or the log statement stuff, or if you want something a little bit more visual in terms of on your UI instead of buried deep in all that text, we can use something called toasts. This is also a nice way of informing the user that something happened, whether your document was saved on Android or it was successfully uploaded or successfully downloaded or something like that. And if you've used Android for any length of time, you've probably seen these toast messages. These are just little black bars with white text that come up and say, hey, this happened. So how do we do that? There is a singleton object, this class method, if you will, called toast, and we call a method on that class called makeText, and we pass it a context, and usually the context is just this particular activity that we're running off of, not fragments, so we still have to do this within the activity. And then the message, this is just a string, the duration, and these are constants, so don't think you can put in like 600 seconds or something like that. You put in one of, I think there's only 2 constants. One is length long and the other one is length short. The length long is implemented in the second line of code here. So an example of that's just the declaration or the definition at the top there. An example is toast.makeText this. This refers to the particular activity that we're in. Again, we can't do this within a fragment, but there's ways of getting that activity, namely get activity. So there's a method called get activity, which I can show you. And then the message, in this case, just toast, and then how long it is, toast.length long. And then that passes back an instance of that toast object, and on that toast object we just do .show, and that'll actually show. So that's really all we have to do. And what does that look like? So on create, let's see. I do believe I can call it here. I might have to do something else, and if that doesn't work, I'll go back to the activity. So if you remember, on our toast object, really that just auto implemented that for me. Let's reduce this screen so you can see my. Okay, so this is actually. Let's see if that works. I guess that'll. Okay, maybe they updated it. This is a toast. There's usually always one thing in class that I say that's wrong, and that might be this right here that we can't do within the fragment, but I was going to show you a different way of doing it. So length short, let's change that to length, and if we hit Control Space, it'll bring up the autocomplete message and also this really obnoxious window. Let me close that. It'll bring up the autocomplete menu that we can see all the different constants. So there's only 2, so I'm going to switch that over to long. Okay, this window is really obnoxious. Hit enter on that. And so that's a way if the menu doesn't come up automatically, again, Control Space will bring that up in there. And let me go ahead and run this application. Switch over to our Genymotion, as long as it doesn't crash. Yeah, okay, so that was, oh, I was right about that. Okay, so what it's saying is it cannot convert the fragment to a context. That's fine, it's just this guy right here. As I said, we have to get the activity, and we simply do that by that. And I'll show you the other way of doing it from an activity. I thought I'd be creative and actually show you how to do it within a fragment. Oh, okay, hold on a second. These things are really fast. So there it is, the bottom right, center of the screen, and it's going to go away after about 3 or 4 seconds. And that's it. So let me run that one more time. Switch over. There it is. A little black message there. This is a toast. It's long. It goes away. Okay, let me comment that out and go back to my main activity. And let's say I want to call that in my onCreate. So here, so toast, create a toast. Main activity this. Okay, so this will work right out of the box. This is a toast from main activity. And I'm only being explicit about the main activity. This, or Android Studio is, I guess, technically. Oops. I always forget these things never pop up on the screen. Okay, so this is a toast for main activity. Okay, so you see the difference there. When we're working within a fragment, we have to get a reference to the parent activity, and we simply do that just by calling get activity. So if you have that error, let me try to duplicate that error for you. Let me comment. Actually, I'll comment it out. Comment this back in. Commenting in and out on Mac, I'm holding down the command /, which is below the question mark, to comment out those lines. So it's a nice little shortcut to automatically comment in and out lines of code. And I think it's Control / on Windows. I'm not really sure though. And then switch this back to, let's just say this. So it's going to give me this error. I'm going to pull up the error message for you. So half of what I do is not necessarily memorizing APIs or I know how to Android works or I know how to do code or anything. I will say about 75% of the time it's figuring out and decrypting these error messages. So error, no suitable method found for make text, main activity fragment, comma string, int, method, toast make, blah, 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 is not applicable. Well, what it really should say is your first parameter is garbage. I can't use that. It's the wrong type, right? It's just say something of that nature. Well, it doesn't. And so really what you need to learn is what these error messages mean. And the way that I usually do that is code a little bit, compile. Code a little bit, compile. As soon as it breaks, you know at least around where it broke, and you can either undo it or you can investigate that a little bit farther. And then also, Stack Overflow is your friend. And so to get a copy of this error message, you can right-click on it and hit copy, because this is not actual text. You can't click and drag, but you can copy it. So select it, hit copy. So I'm going to copy that actually. I'm going to go over to a Firefox window. Okay, just search there, paste that in there, paste it into Google, and for some reason I'm using Yahoo, but I won't say they're the same, but what I want to do from this method is remove the things that are specific, because obviously this didn't come up with, let me switch over to Google. Paste the same thing in, it's going to give me the same error, of course. Okay, well Google has at least 2 results. What I'm going to do is remove everything specific to my implementation of that error. So the line numbers, main activity fragment is actually a custom class for this, so I'm actually just going to delete the entire method body or parameters there. I might keep that because it's pretty applicable generically. I'm just going to delete the whole rest of that, hit enter. And now we have 600 results. And I could probably pare that down a little bit more. But the first one is a Stack Overflow, which is usually the case if you guys have done any programming. And you can say, hey, I'm getting an error while creating a toast. Hey, that's exactly what I'm having. You scroll down here and it's saying, oh, this is the signature of it, and yada, yada, yada. This is how to do it. So usually the one with the checkbox, if you're not familiar with Stack Overflow. I don't even read the question. I switched right down to the green checkbox. I read the code because I don't really care about the explanation, and that's how I do it. But feel free to do it your own way, and that's how you debug fragments, because you'll probably run into a bunch of issues. That's all I got for you guys. Thanks for coming out, and again, next time we'll have an actual application that's useful. It does something pretty cool. So I'll throw together some more videos for you talking about topics like Genymotion, things like that, so that you can set that up if you're interested. But I will see you Thursday.